the linear expansivity of the metal, if the linear expansivity of the metal is 5 times 10 raised to power minus 5 per Kelvin. 5 times 10 raised to power minus 5 per Kelvin. Minus 5 per Kelvin. Comma. Calculate the variation in the area of the ring. The variation, the area of the ring. The variation, the area of the ring, and the final area of the ring. The final area of the ring. The final area of the ring. Full stop. In brackets, take pi equals 22 over 7. That's to tell you that this is more difficult than others. Take pi equals what? 22 over 7. I'm not getting the solution, Chebie, but it's something that is easy. Happy pi area. Okay, and 1 year from now, you are talking about year 1. So, the same topic, the same thing, the same program that you see in year 1. Just see the nature of the questions. You know that area is pi d squared over 4 or pi r squared only. I just decided to give you hints. Area of any circular object is given as this. So consider the formula. Is either you use that of radius or you use the diameter. Already we solved related questions based on the topic. But this is just purely mathematical. We never applied this, but it's important that you learn all the aspects of a topic so that no matter the level, you withstand the pressure. That's exactly the reason why it is important. You don't just go through definitions and stop. No. No. Okay, anybody? Yes? Say it again, let me hear you. Variation is 38.5. Okay. That's millimeter squared. Please don't convert. Leave it still in that millimeter. Yes, any other? Don't convert anything. Yes, yes, yes. Any? Yes? Uh-huh. 1 point, yes? Just hence and here variation, no problem, yes? 38.5, yes? 38 point, okay, fine. Up to 1.1. Okay, more than 7 of us gave us values. Okay, let's turn to the board. That's okay. You know the most important thing? Effort. When you solve along with others, even when the answer is wrong, you discover that you are learning. Because learning is a process. Don't just write for solution, fold your hand and wait for the board. No. That's learning. Now, from the question, what's the diameter? 70. So my A1 will be, my A1 can be pi d squared over 4. This A1 now can be 22 over 7 times 70 squared. Am I right? All divided by 4. Now, 70 squared is what? 70 squared is what? 4,900. Or you can just do it 70 times 70. This, we cancel this to what? To 10. Directly. 2 here to 2. 2 here to what? 2 to 1. 2 to what? So 70 times 5 times 11 will give you what? 385 what? 0, which is millimeter what? Squared area. That is A1. That's exactly, this is just part of the mathematics. So as you get this, you then come back to the question. What are we looking for? Variation, the first thing. And we know that variation in area is the same as 2 alpha what? A1 into theta 2 minus theta 1. That's what we taught you. And that's exactly. These things are not, I told you, they're not difficult but technical. You need to understand your mass. That is the truth. Don't be afraid of mass. Some of you are mathematically okay, but naturally you are afraid of it. So with this now, we can easily substitute. 2 is here times, what is the alpha? 5 times 10 raised to power minus 5 times, what's the A? 3,850 times what? 120 minus this is what? Is 100. Oh. So what you needed is to check. This time this is what? 10. 10 times this is what? 1,000. I can multiply it to that 1,000 coming here will give us what? Will give us what? 1,000 coming here. It's just adding how many zeros now? It's just adding 3 zeros. Nothing will change, but add 3 zeros. Add 3 zeros. It will be 385. How many zeros now? Adding the 3 zeros will be how many now? Will be 4 zeros. Meaning that I have 3,850. 1, 2, 3. Or what is correct? Times 10 to power minus 5. And I told you, hence you obtain this. Cancel this one now and look for the number of counts. 1, 2, 3, 4 already is off. Remaining how many? You move on to give you what? 38.5 millimeter square. That is the variation. And that's the answer. I'm happy. Some of us here are really okay. That is the result. That's the variation. That's the answer. So no matter the way you see the question in exam, let it not bother your mind because it's something you know. Then they said final. They said final what? They said final Guinea. Final area. They said final area. So for final area, what are we going to do? We now say A2 now is equivalent to what? A1 plus variation. Okay? That is A1 plus alpha A, 2 alpha A1 change in temperature. This is our A2. So I can now say that A2 is, this is 38.5 plus, this is 3850. The whole of this is 38.5. Adding these two will now give us what? 388 point what? 0.5 millimeter squared. So this is 388, no, 388, 388.5. Okay. Yeah, it's correct now. So that's correct. Are we ready now? We will answer this question and then go through the rest of that topic, the theory part of it and applications, and stop. Move over to another area of the branch, because there's nowhere we spend more than 2 days in one topic. Okay, somebody gave us this question. Somebody gave us this question. Now, right. A steel plug. Are you still writing the one on the board? Yeah. Kaka praka. Questions I na solve. It's too many. It will take density. Oh, relative density solve. Yeah, relative density. I can figure about densities, relative densities, and all that. My name revision. We'll go through such. Heat. What we needed here is just go back to the density. Here, density bottle. Here, the relative density bottle of volume this. Of volume this. The temperature. This is expelled. So let me give you the formula. You solve this question. For the ones expelled, anytime you see expelled, under density, we talk about when the masses are used, you say that apparent cubic is equivalent to M2 minus M3 over M3 minus M1, all in brackets, theta 2 minus theta 1. When masses are used there. But when volumes are used, you make use of the same, that V2 minus V1 over V2 over V1 into theta 2 minus theta 1. When volumes are used, you use this. When masses are used, you use this for that question. So go back and solve the question. And then you can return to me for correction. It's talking about density bottle. Density bottle. That is the amount of liquid expelled by heating. By heating. So when you hear expelled, expelled is M2 minus M3. That is expelled. This is this is liquid expelled. The whole of this is liquid expelled. The whole of this is liquid remaining. This one is expelled. This is liquid remaining. This is temperature rise. The whole of after linear, what else? Please, let me have your attention. What else after linear? After area, what else? Thank you. And the three of them are for what? For what? For what? We know it's heat. We know it's expansivity. But this area, this linear area and the cubic, they are for what? Thank you. For solid only. For solid. So let us now represent the same thing, that of the liquid. That of the liquid. So let's represent that of the liquid. And I want to express it this way so that even some of us here that maybe had agri teachers in their SS1 as physics teachers can understand it better. Let's come down to SS1 for this. So let us now come up. I want you to look up here. I am talking about cubic expansivity of liquid. Please write it down. Cubic expansivity of liquid. Cubic expansivity of liquid. We're no longer talking about solid now. Liquid. But at the end of it, we'll now combine all of them and answer questions. Repeat that topic. Again. Now, I want you to look up here. If I pick a density bottle, I will not describe anything on the board. I just want you to listen. If I pick a bottle, a density bottle, like this. This is the bottle. And this bottle has a graduation mark where when you are pouring any liquid, where you must stop. Do you know that all the bottles, for example, drugs and all these things, the liquid, they have mark, okay? To give the volume. To give the what? To give the volume. So every bottle has graduation mark. This graduation mark is the point where you fill the liquid up to. So if I pick this bottle empty and weigh it, if I place it on a scale, I will record M1. I will record what? M1. Showing mass of empty bottle. Showing what? Showing what? You can take note of this yourself. So this is my M1. Meaning what now? I will now pick this bottle, fill it in with any particular liquid I want to determine its expansion coefficient or the linear expansivity of it or the cubic of it. I'll pick that liquid. For example, red oil. Let me use the one you know very well. I can now pour red oil inside this place to this graduation mark. And when I pour this red oil inside here, you know that this bottle is at the room temperature. At the what? The meaning of room temperature is initial temperature is what? The room where we are now has temperature. And every object under this room maintains the same temperature, which is initial. Okay? But if we carry something like gas cooker up to 10 and put them on, place them at various points. After 1 hour, will this place still maintain the same? It will change to another temperature. That's exactly. So at the room temperature, we call it theta 1. We call it what? So what's another name for room temperature? Theta 1, abro name. Thank you very much. So the another name for room temperature is what? Initial temperature. You can take note of it. So let me come back. M1 is what? Again. Theta 1 is what? Thank you. So if I fill this bottle now with red oil and place it on a scale, will it weigh the same thing like when it was empty? No. So the new mass now will be M2. Will be what? M2. Will be M2. And this M2 means mass of the bottle plus the liquid at room temperature. Please repeat the statement. Mass of the bottle plus liquid at room temperature. Again. Mass of the bottle plus liquid at room temperature. Thank you. That is M2. Now, I'll place this bottle now with the content on top of, so I will now put it inside boiling water. This is heat is applied here. This is water. I'll carry this bottle into the water. I'll carry it inside this water and start heating. And as I heat, I'll be looking at the thermometer inside here, because you place the thermometer inside here. This thermometer will begin to graduate, move up until at a time the mercury will no longer go up or come down. And we know that I have obtained θ2, which is the final temperature. Which is the what? At that point where you obtain final temperature, at that point exactly where you obtain final temperature, you remove this bottle. You know that as you heat this water now, the bottle is heated. You know why you refuse to place it on top of the fire directly? Because it will break up here. But inside the water, no, it will not break. So as you heat the bottle, the content will begin to film up. And you see air going out up here. That air going out shows that the content is reducing gradually. That liquid, that red oil inside is gradually reducing. The volume is reducing. The mass is reducing. So at that point now where you remove the bottle, you place it now on a scale. When you remove it from the hot water and place it on a scale, will it weigh the same thing as before? No. You will now obtain what is called M3. What is called, Guinea? M3. M3. So M3 means mass of the remaining content and the empty bottle. Mass of the remaining content and the empty bottle after heating. After what? That is M3. So M3 will give you the mass of the content, remaining one, plus the bottle after heating. That is M3. So with this now, that's where I formed that information there. So let me form the information again. But before then, let me ask the same question. Let me have your attention directly here. Everybody, stop writing. Can I have your attention? Stop writing. M1 is what? Thank you. θ1 is what? M2 is what? Plus at room temperature. Thank you. θ2 is what? Final temperature of this system. And the M3 is what? After heating. That is after heating, the mass of the liquid plus bottle after heating. So if I now want to form the information here, I'll come back and say, with this, I have what is called apparent cubic expansivity, which is M2 minus M3 over M3 minus M1 into θ2 minus θ1, meaning that this YA is the same as the upper one is mass of the liquid expelled, mass of the liquid removed from the bottle during heating. It means that when you remove M2, when you remove M3 from M2, what is remaining is that liquid that went off, the one that expelled. That is the one. The volume of the liquid that went into the air that you can no longer bring back. That is exactly the meaning of this mathematics here. So up here is mass of liquid Mass of liquid expelled. Expelled. So this is the one on top. But this one here is mass of remaining liquid only. Remaining liquid only. That is, you know that M1 is mass of what? Empty bottle. So when you remove M1 from M3, what is remaining is just the liquid, remaining liquid only. So this is this one remaining. Then the difference here, I'll give you temperature rise or change. Thank you. So this is exactly what you have. That's exactly what you have. Which is the same as when related to temperature, when related to density, as V2 minus V1 over V1 into theta 2 minus theta 1. Thank you. So this is what is called apparent cubic expansivity. Please put it down. Put it down the same way. And then let's conclude after a few minutes. If you are confused anywhere, I want you to understand these things because these are things you see in exam. Anyone you feel that that's not clear, point out immediately. And be a good reader. Don't just, after writing this, leave the note for the note to read itself. Then you forget. You're a human being. Read through this again and again. It will be part of you. It will be part of your life. You will discover that there's nothing too odd. That is really. Are we through? Can I move on now? Can I move on? Thank you. So let us now look at the whole thing. So we are talking about cubic expansivity of liquid. This cubic expansivity of liquid, we started with its apparent cubic. Understand the apparent cubic. Then you now come back to the cubic, general cubic of the bottle. That bottle is solid. You know the bottle we use here is solid up here. You must bring it in by saying that Y alone means cubic expansivity equals 3 times alpha. 3 times what? That is the cubic. So I have equation 1. This is interpreted here as equation 2. The follow-up of it as equation 3. And then this as equation 4. After the equation 4, I discovered that anytime they ask you a question based on this, that what you are looking for is real cubic expansivity. Is what? Again. So for me to determine the real cubic expansivity of that liquid, I'll come back and say YR, which is real cubic, equals YA plus Y alone. This is the last one. So in any exam, they may give you anything related to cubic, apparent cubic, and ask you to determine the real cubic. The real cubic. So this is the summary of everything called volume expansivity. This is the mathematical summary of it. Volume expansivity. I'm going to draw one particular question now from old from the past of 80s. I'll just draw one question only. Before we now answer the question somebody gave us here. And then we now work on this cubic and stop. Because we have the theory part to discuss, like the advantages of heat, disadvantages, applications. Those things are important. But if we look at our time and see that we may not meet up going into the introduction of the next topic, I will leave that for you, and then I'll get questions against your next class. I will allow you go through it because you have work to do, much work to do. All the areas that are mathematical we can go through them. But those areas that are theoretical, you can as well do a lot of work there and then return the information to us. That will help us move forward, because if you look at the summary of what we are talking about, it's much. If we continue to mark time somewhere, we will not finish up, because chapter 1 to 11 alone is mechanics. And we touched some of them. There are some again we'll go back. It's compulsory that we must go back here and touch some under this mechanics from chapter 1 to 11. It's a must. Then, from chapter 12 to 19, we have heat. So we already started heat now from 12. We started heat from here. And heat continued till 19. This is JAM syllabus, so this is a summary of JAM syllabus. If you have JAM syllabus in your phone, that phone on is okay. But it's a deceiver. Phone now, when you want to go through the summary, the syllabus and other things, something else will come into your mind. Why not you chat somebody? So I told you, when you want to read, keep it alone. Keep it. In fact, pretend as if you don't have phone. Whenever you want to read, so that you climb far, you go far. Don't just do the normal way. No. So please, it is better you collect. The printed one. The main booklets, I'll give the photocopy of the main booklet on Wednesday to the office of different subjects, single, so that you can collect anyone and do the photocopy by yourself. It's better you have that handy one than no phone, a chobana phone on use a pack here. And it is good for you to read using your syllabus, because it will make you to cover everything. For this exam, don't leave any stone unturned. If you know you want to get to that level. Very, very important. So we are here now. Chapter 12. We want to summarize chapter 12. So that we'll go to 13, 14, 15, 16, like that, till 19. And then you have 20 to 28, which is waves, all aspects of waves, all the areas of waves are there. The three aspects, the water waves, you see there, the light waves, all through both prisms, plane mirrors, lens, applications, and all that. Then the sound waves, all through. All of them are here. So you talk about 29 to 29. 29, normally 29 is drawn from the distance, but 29 to 34, they are all electrical. Electricity. All the applications, these are joined together, everything with the system of magnetism. Yes? You have a question? is equation 3. Equation 3 and equation 1 are the same. Yes, they are the same. The only thing is that you use volume at certain level. This question you gave me now, a blacksmith, it was answered last week. Am I right? A blacksmith, go back to your note. The expansivity given to you is 6.3 times 10 raised to power minus 6 per Kelvin. Is it not in your note? Check your note. Is it not there? Some people will just copy question without checking back, checking their questions. It's already answered last week now. Under what? Under cubic expansivity and area. Under cubic expansivity and area. Please, the mistake they made in that book you copied this question, where they wrote real is not real, area. Correct that mistake, where you copied this. It is area. He said the real expansivity, no, is area expansivity. Please correct it. Yes, somebody said, ask question. Yes. YA plus Y. 2 YAs as how? Okay. That's what I said. Now, equation 1 and equation 3 are the same. Equation 3 is used when volume is given. When they give you volume, you use equation 3. But when they give you what? Mass. You use equation what? Equation 1. Normal Y is cubic expansivity. It's already in your note. If you go back to your note, the first equation is Y for cubic, which is 3 times alpha. Is the normal Y. And this 3 times alpha, if it is under solid, they gave it to us. If it's under solid, they gave it to us as what? As this. That is the Y. But we are talking about liquid now. Liquid. Because liquid must use solid, which is bottle. There's no way you pour liquid on fire, heat it, raise the temperature. No. So this system is because liquid is involved and bottle is involved. And bottle is solid, which is the container. Okay. So please, let me give you the simplest question here. Let me copy question from it. It's the simplest for this. Write down. The simplest anybody can solve water in here. An empty bottle of mass. An empty bottle of mass. Empty bottle of mass. 50 grams. 50 grams. Contains please change that word. That contains. Change it to weighs. An empty bottle of mass what? 50. An empty bottle of mass what? 50 grams. 50 grams. Weighs 252 grams. 252 grams. 252 grams. When filled with paraffin oil. When filled with paraffin oil. When filled with paraffin oil. When filled with paraffin oil at 20 degrees C. At 20 degrees C. At 20 degrees C. And 250 grams. 250 grams. 250 grams when heated. 250 grams when heated. 250 grams when heated to 100 degrees C. When heated to 100 degrees C. When heated to what? 100 degrees C. Full stop. Full stop. If the linear expansivity of the bottle, if the linear expansivity of the bottle, if the linear expansivity of the bottle is 2.5 times 10 to power minus 5 per Kelvin, comma, to power minus 5 per Kelvin, comma, calculate the real cubic expansivity of paraffin oil. The real cubic expansivity of paraffin oil. The real cubic expansivity of paraffin oil. Full stop. This is the smallest question that will express the whole of this. This is the smallest. So take your time. Within 1 minute, examine this and then solve for me. Just follow the same guide I gave you. That is the learning. Number 1 formula. Number 4 formula and number 5 formula will solve that problem. Number 1, number 4, and 5 will solve this one. No, you solve. You solve directly. You don't convert because this is per Kelvin. Anything per Kelvin, you don't convert. You only convert when you have Kelvin. I said it the other day. Whenever you have P, Kelvin, you don't convert. But Kelvin, that's the time you convert. I don't want to see hands so folded or somebody resting the head because you can't solve. Please, you can solve. Do something. Begin with the apparent. Write down the apparent. Substitute the values. Substitute the values well. Yes. Thank you. These are fast ones. 2 point minus 4 per Kelvin. These are fast ones. Yes? Somebody raised the hand here. Okay. Change it to standard form. Yeah, that's 7.5 exponential what? Change it to standard form. Change all your value, your final value to standard form. Yes? Say it again. 2 times 10 raised to power what? Minus 4. This first person got 2.5 exponential. This is 2.0. The other is 7.5 exponential minus 4. That's your final. I'm talking about final. Final. All final. I'll go on my pencil now. Who is the owner of this one? Okay. Yes, any other? Are you raising your hand? Okay. 2.5. 7.5 exponential minus 5. Minus 5. Exponential minus 5. I've got 3 different answers. Yes, yes, any other? 2.0 exponential minus 4. In line with this other person. In line with this other person. Yes, any other? Two. Again. Minus 4. Okay. 3.7. 3.75. Minus 4. Okay. Different 4 answers already. Different results. Yes. Okay. The last one, Again. 2 times 10 raised to power minus 3. Okay, but the vary with these ones. Yes? Minus 4. 2 times 10 raised to power minus 4. Okay, now stop. Stop writing. Finally, yes? Minus 4, 2.0. Now, stop writing, everybody. Stop writing. Let us now look at the results. I'm happy that some of us are really mathematically okay. So let me have your attention. From that question now, let's assess the question. From that question, what is our M2? 252 grams. What is our theta 1? 50 up here? Okay, 20 degrees C. What is our M1? 50 grams. What is our M3? 250 grams. What is our theta 2? 100 degrees C. Okay. Then our alpha is what? 2.5 times 10 to power what? Minus 5 per Kelvin. These are the parameters. So with this, the first thing here, I can get my cubic first or apparent, anyone. Anyone. I can say cubic y equals 3 alpha. So that cubic will be 3 into alpha is 2.5 times 10 to power minus 5 per Kelvin. And we now use this to multiply the one inside. That means cubic will be, this time this is what? 7.5 times 10 to power minus 5 per Kelvin. So this is cubic already. This is the cubic expansivity of that bottle, of the container. Then we now come back to the liquid itself by saying YA equals M2 minus M3 over M3 minus M1 into M1 into theta 2 minus theta 1. I will check it. That YA now will be. This is what? 252 minus what? Minus 250 over. 250 minus what? Minus 50. Into what? 100 minus minus 20. That is all. You need to just substitute normally. Now, 252 minus 250 is what? It's 2. So you rewrite the values. So this one now, YA will be 2 over this minus this. So I have here 200 times what? Times 8. So this can cancel this to 1, this to 1, this to what? So YA will be 1 over 8000. Okay? Now, 1 divided by 8 will give us what? 0.125. Thank you. 0.125, which means 1.25 times 10 raised to power what? Minus 4 per Kelvin. That is the apparent cubic. I will now change to the real, which is cubic plus apparent cubic. So real will be, cubic is 7.5 times 10 to power minus 5. Am I right? Look at the cubic here. Then added to 1.25 times 10 to power minus 4. Adding this together does not require a calculator. This is what you are going to do. Stop writing and look up. In your exam, pick this one. Check how many zeros here. Please look up. Minus 5 means how many zeros? So I will just write 0.1234. That is 5 zeros now. And what's the number accompanying it? 75. This is how you record it. Look at the board, please. Then how many zeros are here? So I will add 1, 2, 3, 4 now. And what's the number? 125. Okay? I will then add. This way you are adding is the same thing as the use of scientific calculator. It's the same way. But because in exam, no scientific calculator, you add manually this way. By saying 5 plus 5 is what? 0. Carry 1. This is what? 10 plus what? Which is 10 up here. So 0 again. This is what? 2. And I have here 1, 2, 3, 4. So 2 is the first number here in the whole. So I will write 2 times 10 raised to power 1, 2, 3, 4 in front of it, minus 4. So YR equals this. So this is the answer per Kelvin. That's the result per Kelvin. I can divide them. 1 divided by 8 cannot go. I divided it already. Now I asked you that question. Look at what 1 over 8. 1 over 8. 8 into 1 cannot. 0 point. Into 10 is 1. 10 minus 8 is what? Into 20 is what? 2. Remember what? 4. Into 40 is what? 5. I can't divide. You know that this is possible to divide in your computer. 1 over, that is 1 over 8,000 is possible for the computer to divide it. The calculator and the computer is not scientific. It can divide this and give you the result. It's very, very possible. It divides. It's not going to be, give you the value if you multiply. 2 divided by 200. How? 2 to 1 into 200, is it not 100? It's not 2 divided by what? How can you do that? You can't magic in them. He gave me 2 divided by in bracket 200 times 80. 280 are on the same line. They are on the same line. You can't make that mistake. getting a fraction when a number is still pending. No, calculator will not recognize it. That's exactly where you are making mistakes in even the use of your calculator. Your calculator can solve so many problems directly without issue. For example, the calculator can solve this thing directly. That's why they don't want you to use scientific. Okay, this system now, I am looking for YA. What you needed in your calculator is to tell the calculator what you are doing. For example, open a bracket. Go to your calculator, press bracket open. Bracket open. You press it here. Then 252 minus 250. Close the bracket. Divided by another bracket open. 250 minus 50. Close the bracket. Another bracket open. 100 minus 20. Close the bracket and press equal sign. It will give you that answer if you're in order. The answer. That's why Jam don't want you to use this because there are things you manipulate without even solving anything. So many things in your math and your physics, calculator will just work out those things, give you the result directly. So they don't want you to use the scientific. That's why they had to. In fact, everything about it removed. So that's the issue. While you are using the calculator, you are learning for your own tomorrow, not for the jam. But you still make use of your mind, your own brain. Because your brain is a super calculator. Not brain will be calculator, so brain will be super. Brain will be super. Just like adding things like this, you just need to exponential. Okay, like in your calculator, this 10 raised to power minus 5 is not to be used in calculator. Calculator, Maria, EXP. EXP already stands for 10 raised to power of a number. 10 raised to power of a number. That means 7.5 EXP. EXP minus in brackets. Calculator with bot name with minus in brackets. Minus in brackets. Minus in bracket 5. Then plus 1.25 EXP minus in bracket 4. It will just give you the result. But that's the reason why normally in SS3, SS2, SS3, we teach the students the use of the calculator because already in your year 1 you make use of it fully. Especially these calculators with 96FX that can raise equations, manipulate the rules. Those calculators that are higher than that of the WAEC own 82FX. When we 96. And then the ones that can retain stored equations in them. If you say exam, like, okay, this one, like this one now. 1, 2, 3, 4, FX, AB. Cashew, yes, Nkavu 92. Nkavu 92. Okay. Check it 96. This is 96 because it can retain equations. But there's no way you enter exam hall with it. This is something you're supposed to learn. Even WAEC themselves know that you can save this manual, save these equations, make use of them. Even program it in exam. They decided to bring their own directly that cannot go into such program. That's why during WAEC exam, they say don't use any other calculator except WAEC own. Anybody in this strong and further maths can use equations in the calculator, solve problems without even working anything. So that's the rule. So you don't do that kind of mistake. You get me fraction before multiplier with the one still under. No. You can't have magic or brother mass. Okay, so this is just the standard. Now, that question, can I have the question now? Let me give it to the class. As of I will change over. Let me have the question now. Yeah, now wow. Time I have go for okay. Let me read the questions for you. This is the question that led us to working on this particular area. But because that's what I'm supposed to go in after the applications. The applications, the class can do it for us. Everybody. Please, let me remind you, because of our time, write down what you are going to do for me. Write down what you are going to do for me. Write down 10 advantages of expansion. 10 advantages of expansion. 10 advantages of expansion. Comma. 10 disadvantages of expansion. 10 disadvantages of expansion. 10 disadvantages of expansion. And 10 applications. 10 applications. 10 applications of expansion. 10 applications of expansion. Applications. Applications. Let me ask the question now. Who can give me just one application, just for you to understand where I'm going to? One of the commonest applications. One of the commonest applications of expansion. Thermostats. Railway lines. Or advantage or disadvantage. Job applications. Thermostat is application. Something like what? Bimetallic stripe. Thank you. Come because at least I won't know my questions. These questions, try your best. Don't just depend on anybody. This is, look, you are trying to expose yourself. That's the last part of this particular topic number 12. Here know number 12. And then we go number 12. Here there are except applications, advantages, disadvantages. Please try and get 10 of all this. It will expose you to anything you see in your jump and screening, you'll be able to answer. Meanwhile, let's answer the question because of our time. Now, right. A relative density bottle of volume. 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 50 cm cube. 50 cm cube. 50 cm cube. Edego. Ihapri kwesi na park mgongo. Hell. So bad go kwa oh. Oh. I repeat. A relative density bottle of volume 50 cm cube is completely filled with a liquid, is completely filled with a liquid at 30 degrees C. At 30 degrees C, full stop. At 30 degrees C, full stop. It is then heated to 80 degrees C. It is then heated to 80 degrees C. To 80 degrees C. Such that 0.75 cm cube. Such that 0.75 cm cube of the liquid is expelled. of the liquid is expelled. Of the liquid is expelled. Of the liquid is what? Is expelled. Is expelled. Full stop. Calculate the apparent cubic expansivity of the liquid. Calculate the apparent cubic expansivity of the liquid. Calculate the apparent cubic expansivity of the liquid. Full stop. Apparent cubic expansivity of the liquid. Boom. That's the question. There's nothing else here except A, B, C, D. Whatever. That's all. Then look at that question. You can answer it. So look at it immediately and attend to it. A very simple question if you look at it very well. Look at that question critically and then substitute for the values. Then you just get the answer. It will not take you up to 1 minute. Oh, yes? Huh? What? 2.9. 2.9. There's a error. There's no error in that question. Huh? 0.75. 0.75. Where is 0. Can you hear me? Or 0. What? Or 0.75? Can you? Not correct. You want to Piaro 0.05. The person that copied the question, not the correct. So when one mistake, it didn't the question I copy. Not the very, very, very correct. Yes? Somebody raise the hand here. 3 times 10 raised to power minus 4 per Kelvin. Yes? The same thing. Yes? Yes, yes, yes. The same. Are you for the next class? Huh? Okay. Okay. Mm-hmm. Are you for the next class? Hmm? Okay. Mm-hmm. Minus 4. 3 times 10 raised to power minus 4. Okay? Yes, yes, yes. Uh-huh. 1.31. Yes? 3 times 10 raised to power what? Minus 4. Minus 4. Minus 4. Okay. I know we more look since. I know we more look. Can you with now? Okay, 3 exponential minus 4. Okay, let's go back to the question. Oh yeah, look at the board. Now, from the question, what's the first parameter in that question? V1. Is V1 there? Yes. What is it? 50 cm cube. Next one. Theta 1 is what? 30 degrees C. Next one. Theta 2 is what? 80 degrees C. Next one. V2 minus V1 is given as what? 0.75 cm cube. They said, look at it now. My name has placed. Asigna na M2 minus M3 bo volume of what? Mass of liquid expelled, or V2 minus V1 will be volume of liquid what? Expelled. Expelled. The one that is expelled. And if you look at the question, anyone expelled in that question, look at it. Is that anyone expelled? Meaning that is already in that question. It's already in the question. So what you needed is just to substitute this directly. So apparent cubic is V2 minus V1 over V1. Change in temperature. So that apparent cubic will be, this minus this is 0.75 over. V1 is initial, which is 50, into temperature here is 80 minus 30. So that apparent will be 0.75 over 50 times 50. 50 times 50 is what? So 0.75 divided by 2,500 will give us what? 3 times 10 raised to power minus what? Minus 4 per Kelvin. That's the correct answer. That is the correct answer. That's the correct result. What you need is just the parameters. Hence, you have the parameters. Arrangement is just the same. Substitute and get your values.